Getting situated here. All right, lots of clicks. Okay, cool. All right, well, thanks everybody. So we have a little time here. I think we have till like about 40 minutes. I don't think I'll need that much time. So either we can have a discussion, maybe answer some questions, or we can go right into Matt too, and have maybe more of a discussion when Matt is done. This is a presentation I gave at NWA. I did it in about 14 and a half minutes, and it really probably needed about 29 minutes, so double that time. So I really appreciate Randy and Kelly asking me if I could do this a little slower. So I appreciate that, because I do think it's important material. At least it might lead to a good discussion. That's what I'm hopeful for. So the future of weather forecasting in the era of statistical meteorological guidance. And I think one of the things that I would like lead off with this is like, I would say this is the world according to Chad. That doesn't mean other people might have the same thoughts or agree or disagree with this. But, and I did get a little insight from others on this, but a lot of it's my own thoughts and how I would attack a problem. And I think the goal would be for me to present this to you all and just have you take it and run with it, and see what you can do with this mindset of the forecast process, at least with respect to messaging. So I'm sure many of you have heard these quotes that I'm going to share. And honestly, some of you may have said these as well, and that's okay. The first is the NBM is going to take the meteorology out of the forecast process. We've heard that one quite a bit. If you just start and go with the NBM for your forecast, then there's really no point in having meteorologists. I'm sure we've heard that one as well. And then finally, the NBM cannot forecast high impact events. There's no way that that's happening. And if you've said these before, I'm going to say that, that's okay, because I think that, regional headquarters, and not all of them, but at least initially, and even national or NWS headquarters probably could have done a better job with basically spelling all this out for people about the NBM and how to use it and and all that, and because it's really not doing these things. These are myths, and I'm hopeful that you'll end up seeing some of that, by the end of the presentation. And I think a lot of these myths and these quotes and these thoughts and these discussions that forecasters have on a midnight shift on a Saturday evening, they're really all driven by human bias, and I think that's a big part of it. It's not always the case. It doesn't need to be the old forecaster. It could clearly be the young new one as well. I've heard both flavors tell me these things before, but because it's led by this bias, I believe a lot of it's education, like I said. That's what I think. But as Dr. Goldfarb said during his NWA keynote in September, he's an economist from the University of Toronto. Prediction is about using information you have to generate information you don't have. Okay. Anywhere you have lots of information, he says data as well, so very similar, and you want to filter, squeeze, or sort it into insights that will facilitate decision making, prediction will help get that done. And now machines can do it, okay? And I want you to think about this quote, right? Because this is a really important quote. And it's because it's basically what we do, right? And in my opinion, our machine So our machine that's crunching all this data and these numbers is the NBM. You know, the NBM, this is how the NBM team defines this. The NBM is post-processing calibrated forecast guidance that's based on a blend of both weather service and non-weather service numerical weather prediction model data. It's not a model. It's a blend of models, or it's our machine to basically interrogate all that model data for us to provide actionable information. And I really hope that people are starting to think like that. And I think a lot of central region forecasters are doing that. You guys, in my opinion, are pretty far ahead. Western region is catching up very quickly. We're starting to catch up, I believe. But I think that many of you are thinking like that. And the goal of the NBM is to create a highly accurate, skillful, and consistent starting point for the official NWS gridded forecast, right? And that's really the goal. And this is from like the NBM. This is from the NBM team, and you know, and many of you know this information. But if you want to know information, I highly recommend going and finding Dave Rudak's presentation, and he has a preprint as well. It's like all things NBM. He gave it at AMS 2020, I believe, before when we could travel. But I would recommend going back and looking at that document. So that's what I believe our machine is, right? And like there's other machines, like really like the EPS is a machine, the HREF is a machine. They're like mini machines, right? Because all this data is in the NBM. And that's really the goal. And I think that's what we need to think about it. It's a starting point, but it's also a machine that can provide us really, really great information. So why, and I still think that scares people. So what I want to do is I want to show you basically this proposal that I make of NBM statistical guidance is trying to woo meteorological analysis forecasting and getting her to really marry the NBM statistical guidance. Okay, and that's basically what I'm going to show for the remainder of the slides. And again, this is my approach to this problem. So how do we go ahead and like tie the knot here, right? So the first thing that I would recommend is analyze the NBM guidance for threat signals, okay? So use like the 95th percentile. And when you're seeing somewhat extreme values there somewhere in the forecast, that's a red flag. I would use the max T information. These are the types of tools that I would kind of look at, and I would go through and start basically writing down quote unquote targets of opportunity in the forecast, okay? And then I would start to apply conceptual models and applied research. Now 2 and 3, they kind of go hand in hand, and I'll kind of show this. But the reason why I put number 2 first is because you almost have to have this knowledge, this ongoing knowledge base of conceptual models and applied research that's being introduced to forecasters along the way. Maybe it's seasonal readiness type information, but it needs to be ongoing, I believe. And I think it needs to be reintroduced because refreshers are always good. But number 2 and 3 really go hand in hand. And yes, I did say analyze deterministic guidance, because like if you think about like the far right from you know, Dr. Craven et al, you know, he might slap me around for saying that, but I really believe that you need to be able to analyze. In order to have an understanding of the forecast, you have to analyze some deterministic model output, because it's really the only way to apply those conceptual models. Because once you start using ensemble output, that kind of, you know, that all kind of goes haywire, right? We're averaging, we're looking at percentiles and things like that. It's super critical, and it's a step, right, that I'm proposing. But I think you need both, and it's a conceptual understanding of the forecast, right? That's what number 3 is like really keying in on there. And then number 5, analyze NBM one-dimensional probabilistic output. So like looking at point data, I think it's super powerful to do that. So the NBM 1D wave viewer, the NBM text bulletins. So you all should be getting those in AWIPS. You can find them on the web very easy as well, but you also can look at them in AWIPS. There's 5 different text bulletins from the NBM, and they're all very valuable. And then lastly, and most importantly, it's messaging the context of the upper, and I say lower there, but it really should be and lower, messaging the context of the upper and lower bounds, okay? That's critical. So this is kind of like my recipe. Now, as I've been talking to others about this, I think like, you know, quote unquote steps 2, 3, 4, and 5, you know, could be jumbled together. You know, like if you think about the recipe approach, number 1's the bowl. You know, you put all the ingredients in the pot, or number 1's the pot, and you put all the ingredients together, and it really doesn't require them to be in a certain order. Number 6, you're basically trying to cook it. You know, and you can almost think about like, you know, making chili like that, right? So like it doesn't really matter the order, but you need all those ingredients, I feel, at least to have that conceptual understanding of the forecast, okay? So this is like my recipe. That's how I'm tying in that. So I was doing this in real time, okay? Last January and February, when we had high impact QPF events, they were synoptic scale, clearly because we're out of tropical season, but high impact synoptic scale QPF events, I would do this in real time, okay? And I got pretty good at it after a while. And what I'm going to show you from here to the end, basically I could get done in about 45 or 50 minutes, okay? And this was like really doing it a few times, but the whole process, it was like basically 45 to 50 minutes it took me. So it can be done like anything. And I think that's enough time that where the forecaster really wants to dig into the data and really needs to, you know, you can do that over 45, 50 minutes if the priority is set. So the time period when I was doing this in real time was basically, and I have 16Z there, so it was like 10 a.m. in that 10 to 11 o'clock hour on January 7th, I was doing what I'm going to show you in real time, okay? And I would write like a journal. So here's the journal from what I did. On February 7th, I put these dates down, and I don't need to go through this because I'm going to basically show you all of this now. But I just kind of wanted to show what I was doing. I was kind of typing it out and making notes, and I was sharing it with the Southern Region ROC ER Mets. And we've had a really good interaction between myself and at Southern Region STSD and them. And we've really done a lot with messaging tropical, high impact, worst case scenarios during these tropical events that we've had. We've gotten really good at them because we've had a lot of them. But that's for another presentation. The approach is somewhat similar, but there are some unique aspects to tropical. Okay, so like I said, the first thing I would do is analyze NBM guidance for threat signals. So here's like NBM 72-hour QPF. This is the mean field, and it's showing a pretty good area of this orange area here is basically 5 to 6 inches from northern Louisiana to northern Georgia. This embedded part area here is 6 to 8 inches, but really a large area of 5 to 6 inches from northern Louisiana to northern Georgia. Okay, this would be a red flag So I saw this, I'm like, okay, we need to start to dig a little deep. Now, in full disclosure, this was a Friday, February 7th was a Friday. I started doing it on Wednesday. So Wednesday I did it, Thursday I did it, and then Friday I did it as well. I did it the days after, but this is kind of the one I was showing you. So we're going to be looking at this event in the day 5 to 7 day period. So pretty far out. Most people would consider that pretty far out in the forecast. So now know your conceptual models and applied research, okay? And this event was basically textbook, Maddox et al., the synoptic scale, Maddox et al. Event from 1979, okay? So the surface, basically we showed a weak surface low with a quasi-stationary front. Convection would form along the front, it would train, and then you would get heavy rain on the warm side of the front. A little further aloft, 850 flow would be anticyclonic, but really along that surface boundary. You'd have a pretty strong low-level jet there, but really pretty weak 850 to 300 wind shear, which helps things slowly train over the same area. So you get that elongated QPF swath. And then aloft, you'd have this strong, slow-moving trough, usually pretty far back to the west. So maybe Texas, even New Mexico, Arizona area for a QPF threat over the southeastern U.S. So, but really large-scale trough ridge pattern across most of the CONUS, but slow-moving. So you get multiple days of precipitation, okay? And then you can see that the winds aloft would parallel the surface front. So this is, again, this is all conceptual model, but just having this knowledge in your head, right, ahead of time, to be able to identify this event really quickly is super helpful, okay? So this is like that knowledge base that really should be in the forecaster's mind ahead of time, okay? Now the applied research, right? So this was applied research by Mahoney et al. 2016, understanding the role of atmospheric rivers in heavy precipitation in the southeast United States. And I know Matt Jeglin is on, and I just want to make sure that he remembers that atmospheric rivers are not just a Western region phenomena. And Dr. Mahoney et al. Really hit this home, and this is really applicable for this event. But what they found was basically over half or slightly over half of large-scale heavy precip events in the southeastern U.S. had an atmospheric river associated with it. This was their criteria, and out of this research, they basically created this automatic detection of atmospheric rivers. It's a really great tool. Right now, it's based on the deterministic GFS, I believe. But it's really helpful. So if you see the automatic detection, and here it is in these white dots that are connected, I think in the on the website they might be gray dots. But when you see this pattern, boom, that rings a bell. Okay, it gives you confidence that over half, when you have this, over half of heavy rain events had 4 inches or more precip. Again, you're building confidence in the forecast using all these tools. Okay, so that's number 2, knowing your conceptual model and applied research. But that's why it's important for the SUDs out there to introduce these really applicable research papers and these conceptual models to forecasters. And it's not only meteorological conceptual models, it's also applied research, or it's also statistical. And there's going to be great training coming from the OCLO on probabilistic training. I can say it's great because I'm a part of the team, Matt's a part of the team of subject matter experts that's really trying to shape this research and make it very applicable for the forecaster. But you really need to understand when the distribution is shaped a certain way, what does it mean? So if you're looking at a positive skewness, there's strong outliers that are skewing this distribution to the right of the central tendency. Okay, so now let's look at that deterministic model output. So here's the 6Z run from the GFS. You can see that this was valid on Tuesday. So we're looking at a 96-hour forecast, but you have a front, you have a very weak surface trough. Again, textbook Maddox et al. Synoptic. You go moisture. There's plenty of moisture, and you're looking at precipitable water values, 1 3/4 to 2 inches, kind of just to the south of that surface front. Aloft, you have pretty strong low-level flow feeding that moisture, and that's tapped all the way in from the Caribbean for this time of year. That's a very moist flow over that surface front, and then aloft, you can see that there's a trough out to the west, and then southwest to west-southwest flow over that area of concern. So you can see why the importance of deterministic model output. I'm not looking at QPF here. I'm not saying that's bad. I think it's applicable sometimes, but I'm not doing that in order to get a really good understanding of heavy rain possibility and atmospheric rivers, like in this case. So you can see that based on that run, that GFS run, you had an atmospheric river associated, and you can see this flow. That low-level flow is from deep into the tropics, deep into the easterlies across the tropics into this area. So all these things are just giving me confidence that that's something that I needed to be aware of. I need to be aware of. Again, another great tool is on all these ensemble tools that we have that Matt's going to talk about many of them in his next presentation. But you can see that based on the NAIFS, mean precipitable water, we're having climatological values of moisture really in the 99th percentile. So again, all these things point to a heavy rain event, and I'm not looking at QPF. I really haven't looked at MBM too much other than to give me, okay, this is the part of the forecast I really need to look at. I'm using all this meteorological knowledge and data to give me confidence potentially in the QPF, okay? And here, like, so I just showed the situational awareness table, but there's a whole slew of ensemble data, and these are all based on ensemble data in one form or another. Even this NBM output is based on ensemble data. You can say, but you have the NBM forecast records tool that's really great. The cluster analysis page. Weather Bell that many of you have available to you now. So here's the Euro output, the ensemble situational awareness tables, and even analog output. There's just so much ensemble tools that are at your disposal to provide you confidence in the forecast. Okay, so now let's look at some of that NBM 1D probabilistic QPF. So here's the 96-hour QPF. So we're looking at Nashville first. So 5th to 95th percentile. And I'm really going to be focusing on the 90th and 95th percentile to message that high impact event. But really, we also need to be thinking about the best case. And really, the best case is this basically all stays to the south of Nashville. As we get closer to the forecast, that area is refined and you get very little precip in Nashville. And that would be the best case. But the worst case is a potentially pretty heavy rain event in that area for that 96-hour QPF, okay? And here's what the probabilistic density function looked like. And I put that in quotes because this is really a poor man's version. I'm just taking those percentiles and plotting them. I had this in Excel, so I would just, boom, I would write them all down, add up those values, and we can talk about adding those values up in not quickly if we want to. So the best piece of guidance that we could have and we don't have is NBM PQPF based on more than the 24-hour amounts. We need it for the 48-hour QPF. We need it for the 72 hour. We need it for the 96 hour, because these events are sometimes long duration QPF events, and you really need that, but we don't have that. We have winter weather products up to 72 hours where the winter QPF is based on that, but the MBM team never got a requirement for this. I'm going to be pushing for this hard to be added because I really think it's important. So is it really, really bad to add up the 24-hour amount, PQPF amounts like I've done here? It really isn't. Is it a true 96-hour PQPF? It's not that. But what it is it's just something different. And what it is, it's almost like a worst case, especially when you're looking at the 90th and 95th percentile. Because now the statistical probability of 96-hour QPF exceeding 7 inches at Nashville isn't really 95th percentile. It's really like 0.5% or 0.05%. You're way down on the tail when you're adding these up. Now, is it truly that statistically? No, it's probably somewhere in between because these 24-hour amounts aren't independent of each other. They're really connected, but so it's really probably like a 99, right? Or a max, somewhere in there, okay? I just thought it was really important to somewhat explain that because I just didn't want somebody out there kind of rolling their heads, well, you can't do that, Chad. Actually, you can, it's just something a little different, okay? You just gotta be careful. And that's why I kind of put some of this in quotes, okay? So, but it's skewed to the right. So we have outliers in the MBM inputs that are skewing this distribution to the right. And we'll talk about that more. Looking at some other sites, Chattanooga, Huntsville, Tupelo, they're a little higher. And what we're gonna do is we're really gonna focus on Tupelo here, where we're getting into that 9 to 10 inch range. But you can see all of these sites had these distributions skewed to the right, okay? And it's important to kind of go back and show this MBM 72-hour QPF. I know I have different values here, but really think about it. Most of these sites, at least Tupelo, Huntsville, and Chattanooga, they were in that like 4 to 6 inch range, okay? That would have like put you here on the PDF. It's not at the median. The median's like 2.5, 3 inches. The mean was more in this 5 inch range. So these outliers are really pulling the mean to the right. That's another important statistical conceptual concept that is really important for the forecasters to know, that if they're looking at the mean and it says 5 inches and then they're looking at the median that's 2.5 or 3, why are they so different? It's just really important to understand that. Okay, so lastly, and I'm doing pretty good on time, but lastly, how do I take all this knowledge and basically message the context of the upper bounds, okay? Well, one, we have to have confidence in that upper bound, in that 90th percentile, that 8 inch QPF at Tupelo. And we get that confidence by conceptual models, by the GFS in applying the conceptual models, by all the ensemble tools. All those things are telling you that these outliers are really in play. These outliers aren't just out in Never Never Land, you know, like the GFS run that everyone makes fun of at hour 180, right? Well, that actually may be a reasonable, it could be a possibility, right? You just kind of got to go and try to put it in context. Are you getting support from the Ensemble suite with those tools, okay? Does it look like a conceptual model for a heavy snow or a heavy rain event? This is how I get confidence in messaging this 90th percentile. So that's kind of what we're gonna do here. I think I've built a case for that. So where does that 90th percentile fall in the climatological record, basically? Well, at Tupelo, it would fall basically in this number 8-9 period, okay? So like I say, this would be number 8 on the 4-day historical precipitation. And the return, you can calculate the return period from all that information very easily. knowing how large the climatological record is and where it falls on the percentile. The return period is basically 6.5 years, okay? So it's not super often, but it's somewhat often. I know that the WPC has this, I forget what it's called, so I apologize, because I should know that. It's like the climate weather and context, I think it is. And it's great, but I think it's only driven by 24-hour QPF. We really need it driven by more so we can do this quickly. So I don't have to go and do all this work. I can look at that field for a 24-hour QPF or a 96 or a 72 and really get the statistics there, okay? That's basically what I'm doing. I'm doing the weather and context by hand for a 96-hour period. But what I can do then is like, okay, let's look at what were some of the days around that occurred with this 8-inch QPF? Well, we have two events. We have an event from February 2019. Okay, that happened last year, right? So, but that was a little more rainfall. But we also have this February 17-20 from 91. That's actually a pretty good quote unquote analog, right? It had 8.18 inches. That's well within like the margin of error. I think I can still throw that joke in there. It's definitely not too soon. But so let's look at that one. Let's look at this event from February 20 from 1991. Who can't remember what happened 20 years ago, 30 years ago, right? So let's look it up. So what do? You go to Google and you start Googling February 91 Mississippi flash flooding, heavy rainfall. And lo and behold, well, what comes up? Well, some good references about this event in the river forecast gauges. On that event, 56 Mississippi gauges went into flood, 17 gauges exceeded the 10-year discharges, and 6-year had record discharges. And why do I do this? Because one of the things that drives me crazy is when we get a QPF event coming, and what is the messaging? It's messaging heavy rainfall, flash flooding, river flooding, and that's it. I think we can do better than that. And you know what? Google is allowing me to do that by kind of going and finding an analog, you know, the way I did. You know, very, you know, just a smart way to attack the problem. And I can get all this. Well, do I want to message 56 Mississippi gauges going to flood? Well, of course not. But could I message that the possibility for moderate river flooding on day 5 or 6 is high because the historical events similar to this had 17 gauges exceeding 10-year recurrence discharges and 6 went into record flooding? Yeah, I have confidence in that, basically doing all the meteorology that I've done, right? I've only looked at the MBM a little, if you remember, right? I'm using all that meteorology to message with the MBM, okay? All right, and the last thing I'm gonna show, what if that Tupelo QPF was just a bit further south? That's very reasonable, right? On day 6, or I'm sorry, on day 4 and 5, where that front is located, sure, we could be, again, that's kind of within the margin of error. So let's take that Tupelo QPF, that 8-inch amount, let's go to Jackson. And that's what we're gonna do. And same thing, would be number 3 on that Jackson day 4 total. The return period would be 28 years. And now let's take a look at the historical Pearl River crest at Jackson, right? Because some of those are actually these historical river crests. And we're getting these amounts. Even the 10th and the 11th Pearl River crest had these amounts forecast in that area of 8 inches. The record one was 8.54. So you can see this is kind of what we're doing, okay? And that Pearl River basin is pretty large. And even if the rainfall doesn't happen at Jackson or Tupelo, but it happens in between, that's gonna hit that Pearl River crest basin. So what if I'm wrong about messaging that, right? Well, in my opinion, it's about telling them what you know when you know it. It builds confidence, that builds trust. It's not withholding information. right? I'm not scared to message this, right? Because of all the work I did leading up to that information. You know, and if the guidance changes, and this is what Dr. Jocelyn tells everyone, clearly communicate those changes and you won't lose that trust that you gained with your partners. So what ended up happening? Well, at all these locations, you were basically very close to the mean. At Tupelo, you were a little higher than that. I think this ended up being like the 82nd percentile based on that 96-hour QPF that ended up happening over those 4 days. The Pearl River crest for this event in last February ended up being number 3. And you can see that most of the heavy rain did fall between Tupelo and Jackson. It fell in there right over that Pearl River basin that ended up flowing down into Jackson. So the last thing I'll leave you is we really, in order to embrace this concept, we need really good, for lack of a better word, training on these conceptual models and concepts, really embracing going back and kicking it old school, embracing the forecast process in this way. But we need to have a tempered tolerance for change. And honestly, we need to think probabilistically. And, you know, I really highly recommend this book. Dr. Goldfarb plugged it. I'm going to plug it. It's a really great read. I listen to this book when I've been walking in the evenings when I've had time. It's a really great book. Chapter number 1 basically is the cornerstone of meteorology. Annie Duke basically breaks down how poker, and she, for those of you who don't know, she's a retired professional poker player, how poker is basically the probabilistic way to think for life, but it's really for weather forecasting and meteorology. Some of the other chapters after that are very interesting and they kind of help tie things together, but really it's chapter 1 that kind of hits everything home. So with that, you know, I have 5 minutes to kind of like answer some questions, but really, if there are none, I think we should like really lead into what Matt has to show, because it's really going to be the foundation of that ensemble guidance part of this process. So Randy, I'll throw it back to you.